Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. This is Dr. Elena Hyde, and I'm joined tonight by one of our regulars, the amazing Julie Tomei. We will be your hosts this evening, of course, and we're broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. As a reminder, York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. UT, if that's more your speed. The York Universe production works in concert with our online public viewing. So if you're watching this live on YouTube, you're probably already seeing it. It's run by the amazing Observatory team the exact same time, 9 to 10 p.m. local Toronto time. For all of the links to OPV and, of course, past episodes as well as the archive, you can go to www.yorku.ca/science/observatory. Now, of course, we have all kinds of wonderful things planned for tonight. But if you have questions or comments for our past shows, or if you have suggestions for future topics, you can always email us at observe@yorku.ca. And of course, we're on Twitter and Instagram and Facebook with York Observatory, York Universe, and Facebook is Ellen I. Carswell Obs, just to be a little bit confusing. All of our programs are free, but if you'd like to make a donation, you can see that same website I mentioned before, yorku.ca/science/observatory. Right now, we are monitoring the chat room for questions, and of course, our crew is there to present, hopefully, the live sky tonight. How's the weather where you are, Julie?
Hi. It's a little iffy, though I did see the moon rise when I was picking up my daughter earlier. So, you know, some wispy clouds.
It's a good sign if you can at least see the moon, at least, not all hope is lost, so to speak. If you have particularly clear skies tonight, some folks might be a little bit interested. The comet that everyone's been talking about is out, but it's still 5.5 magnitude, so 12 Pons Brooks is, of course, the comet that's going to be visible during the totality, if you're in totality, for the April 8th eclipse. But it still is magnitude 5.5. It will be getting brighter, but compared to the moon, I think clouds are probably going to affect that one pretty heavily.
Yes, probably.
All right. So, of course, moon fans, you will be able to see the moon. And if it does get clear enough, if these little clouds move out of the way for us enough, we'll try to go to some fun objects for everybody later on live on OPV, of course. And just as a reminder, those are all on our YouTube channel now. So we have all kinds of fun topics this week. There's so much going on, but we shouldn't forget what has become before. So I think this week we have a nice set of space and astronomy history. A little bit more back to our regular episodes after a few weeks of chaos, if you will. So Julie, do you want to go ahead and get us started off looking at some space astronomy history fun?
Yes, and I'm actually cheating or giving you a bonus, however you want to look at it, giving you 2 for 1 on this first item. So we are looking at March 28th, 1802, and March 29th, 1807. On these dates, Heinrich Olbers discovered asteroids Pallas and Vesta, respectively. Heinrich Wilhelm Matthias Olbers was a German astronomer who lived from 1758 to 1840. And on top of discovering Pallas and Vesta, he also found a convenient method for calculating the orbit of comets. He studied to be a physician and practiced medicine after he graduated. And he did his astronomy was, his like side hustle. He did it at night, obviously. And he turned the upper story of his home into an observatory. He was invited in 1800 to participate in a group that became known as the Celestial Police, and they were dedicated to finding new planets in the solar system. And so he discovered Pallas on March 28th, 1802, and 5 years later, Vesta. Um, almost on the anniversary, one day later. And he allowed Carl Friedrich Gauss to name Vesta. Gauss was a German mathematician whose orbital calculations helped confirm the existence of Ceres. Because the term asteroid wasn't a word yet, those bodies were referred to as planets at the time of their discovery. And then after a number of similar bodies were discovered, they were referred to as minor planets. And then starting in 1845, that was starting in 1845, they were referred to as minor planets. And then eventually asteroids was the word that came into being in the 1950s. And that was mostly because their formation is different than that of other planets. He proposed that the asteroid belt was the remnants of a planet that had been destroyed, though the current view is that the tidal effects of Jupiter disrupted any planet formation that would have happened in the asteroid belt. So the planet that didn't get a chance to form rather than one that's been destroyed. Apparently, Charles Messier had recorded Pallas on a star chart that he used to track a comet, but must have assumed that it was a star. And so he is not credited with the discovery. And a few months after the discovery of Ceres, Olbers was trying to observe Ceres when he noticed a second body moving nearby, and this was Pallas. Because he observed Ceres and Pallas in the same area, he theorized they were remnants of a destroyed planet. He wrote to William Herschel, friend of the show, suggesting searching for more fragments in the same area, and he started his search right away and then found Vesta in 1807. This, of course, was a coincidence since the asteroids, as I said, are not fragments of the same body.
Very fun stuff.
Yeah.
And of course, Messier being in there, this is still technically Messier Marathon season, where we celebrate this fellow who is very good at finding things that he wasn't interested in, but other people were. So I suppose we can add these to the list.
Yeah.
Another thing he wasn't particularly interested in, but turns out actually pretty cool. Vesta and Pallas, of course, now we're interested in them for lots of other reasons, and it is pretty cool because, if we're talking about his discoveries for the asteroids, most people probably don't know him for this because, of course, he is also Olbers of the Olbers paradox.
Indeed.
And this is a pretty famous one for astronomers, which asks, why is the night sky dark if there are so many bright stars all around to light it? And this is true. There are bright stars in every direction that you could ever possibly look in the sky. It's just, the distances involved. So the Olbers paradox is a really fun one. And I think, if you've taken a beginning astronomy class, this might be the only thing you know him for. But he did find obviously lots of other things and comets as well. I think he found at least, was it 4 or 5 comets or something like that?
Um,
Um,
there's at least one named after him.
yeah. Up the yeah, and now of course we have another comet up there in the sky to worry about. But this is also, I will say, Pallas and Vesta being these things in the sky, you get a little tiny point of light, you don't necessarily know that it's not a planet, right? So it's sort of understandable to think that he might start off calling them other planets. They're pretty tiny, but they could have been planets. If they'd been a little bit bigger and had a bit more collisions involved, I suppose.
Yeah.
And they're both quite small, actually, right? I think the was it Vesta um, was something like just hundreds of kilometers in sort of the size, as I recall.
I'll look it up.
Yeah, tiny, tiny rocks for space things. Sort of like I imagine it being the Little Prince moon sized, where like you'd stand on it and it would just be a little bit bigger than the person
Uh,
standing on it.
525 kilometers, the mean
Yeah,
one.
so that bigger than a person, but still pretty small compared to a planet.
That's Vesta, and Pallas is, yeah, a little bit smaller, um, between 507 and 515.
Yeah, so 500 kilometers, not very big.
No,
Um,
not very big at all. And I can understand why Messier would have missed it if he was just looking in that area once, because of course you have to look twice for something that's moved.
yeah, exactly. And also these are not comets, so
He was not interested. He
yeah,
was
it was
interested in
not.
fuzzy things.
But some actually, and it is funny because we talk about Messier and comet searching and all that stuff, and their relationship to meteor showers. But actually, some asteroids do cause meteor showers on Earth. So I don't know. I gave 2 degrees of separation for any Messier object, I suppose.
I
Um,
suppose.
in any case, speaking of things that are not planets, maybe I can go on to our next item.
Let's do it.
So I'll go ahead and also sort of pick one from a little bit earlier. We're going all the way back to 1655, March 25th. The Titan, the moon of Saturn, was discovered. And so this was the start of a pretty big deal. So Titan, of course, being quite famous right now for all kinds of wonderful things, but mostly its amazing atmosphere. So Titan is, the largest moon of Saturn. It's a very obvious moon. It's away from the rings, easy to spot, gets a good amount of attention. And Titan was discovered in 1655. This is quite a while ago. So, the exploration of Titan has been hundreds of years in the making since it was discovered by Huygens in of course 1655. And just have to say it to remind ourselves that some of these things we think of as modern astronomy have their historical basis quite some time ago. So obviously, it does require a bit of optical assistance to see, but a Titan now we know it is just one of many, many, many moons around Saturn, and I believe they're actually still counting exactly how many moons because Saturn also has the ring system, the very, very, very fabulous and famous ring system. But Titan is large. It's pretty darn large for a moon. It's in fact, it's so large, many people, and I have mostly planetary scientists, have made the argument that it really is more of a planet than a moon. It's quite big. It's larger than Earth's moon. It's larger. It's actually the second largest moon in the entire solar system. So I think it is larger than Earth's moon, but I'll have to check that. But it's only moon on in the whole solar system that has an atmosphere. It is yeah, so it's 50% larger than Earth's moon. That's what it was, 50% larger, which is pretty big.
It's larger than
Um,
Mercury.
yeah, pretty planet-like, big, massive. It has an atmosphere. It's not as massive as Mercury, but that's mostly due to the fact that it has less dense materials. So Mercury is, of course, the hard baked rock with all of the, well, almost all of the ice is melted off of it. Well, Titan is actually a very large portion of less dense ices of all kinds of interesting descriptions. So 1655, Christian Huygens, and if you haven't heard of Huygens before, he did a lot. So he wasn't just discovering Titan, but he was studying inner rings of Saturn, and he did a lot of inventing. He actually did several major improvements to the designs of telescopes. He invented a pendulum clock, which was, I believe, the most accurate for about 300 years, at least that we know
Mm.
of. He did a lot of engineering, a lot of a sort of hands-on invention. He, of course, helped with development of classical mechanics or the laws of physics as we know it. So this was a decade before Newton. He was already identifying what we call centrifugal force. And of course, he is very well known in modern physics today for his wave theory of light. That's right. Like this guy, he really just did everything. So he was out there absolutely, taking names and doing amazing, amazing things in engineering, invention, really hands-on, but also theoretical. So pretty darn fun. And of course, finding Titan. Once he found Titan, he was able to actually estimate some of its parameters based on its orbit around Saturn. So Titan orbits Saturn at about 20 Saturn radii, and now we're completely spoiled. There's actually amazing moon tracker tools that you can go and just click on online. It'll show you the positions of all the moons, so you can watch Titan go around Saturn if you want. But of course, Huygens did not have that those parameters pinned down yet. He had to measure them himself. And it was quite a while later. So I believe it was about 300 years later. So from 1655 to 1944, um, Huygens' discovery and parameters of Titan weren't hugely changed. It wasn't until about 300 years later, so 300 years, crazy, Kuiper discovered the other thing that makes Titan really, really exciting, and that was the atmosphere. So it wasn't until 1944, hundreds of years later, we finally had telescopes that were good enough to show that there must be an atmosphere on this moon. And yeah, I mean, obviously, we could probably talk about Titan a lot because now, in the wonderful year of 2024, we've had quite some time to enjoy the Cassini mission and the Huygens probe that actually went to Titan, and that was, pretty substantial. So Titan itself, the Cassini-Huygens spacecraft, uh, you know, it was in 2004. So this is now we're talking many hundreds of years later. We finally get a spacecraft that can get direct images of Titan's surface. And of course, Voyager space probes that came by earlier, they took pictures of Titan's atmosphere. They could tell it was denser than Earth's, but what it really was a bit of a debate because it was thick. It's if you've ever seen pictures, most of the pictures will show you some sort of thick, hazy, soup-like atmosphere that you can't see through it. It's not transparent. You can't see the surface. It's got a very extended, so it's a thicker atmosphere than what we have on Earth. You don't get to see much of anything on the surface, but yeah, it was amazing. So the Cassini-Huygens probe, spacecraft and probe, I should say, um, they were sort of a great celebration, I suppose, of that discovery. And we've been enjoying that, sort of views of the clouds, the various different interesting chemicals, because of course it doesn't just have an atmosphere, it has nitrogen, which we have, but very thick. It also has methane, hydrogen, and all kinds of other interesting gases. And because of the temperatures that things are at on Titan, its surface temperature being extremely cold, so it's, I believe, about minus 179.2 degrees Celsius. This means that your water ice there's not going to be water vapor, so to speak. You're going to have a very, very strange greenhouse effect where methane is going to condense and you have ice is made up of all kinds of interesting things. Ethane condenses over the poles when the seasons switch. It's amazing. So I highly recommend everybody to go and look at some of the pictures because of course Cassini-Huygens did drop a probe and it did actually bring back real pictures of the surface, lakes and tributaries and networks filled with ethane and methane and dissolved into just incredibly different, I suppose I should say, chemistry than what we're used to here on Earth. So you still you have lakes of liquid, but they're not water, and you have what looks like solids, but it's not rock. So the Cassini-Huygens really opened up Titan, and now of course it remains a hotspot destination for future missions. I think, being still pretty much the only other, well, the only moon with an atmosphere, and the only other really thick atmosphere that we can deal with. Of course, Venus's atmosphere being too thick to really put a lander on, and Mars is being too thin. It turns out we actually can land on Titan, so I'm really looking forward to, I don't know, the next generation of Huygens probe or Huygens sailboat, perhaps landing on Titan. And of course, there are many various sort of tributaries of Titan we could explore if we had more time. But it all started all the way back in 1655.
Awesome. When you said Saturn has many moons, I was like, how many are we up to? So I looked it up. Do you want to guess?
482.
Maybe one day.
I mean, it's gonna get there eventually. We just haven't found them all.
146.
Yeah.
When I was a
It's
kid, we knew about 21.
I know, right? And that's the contest between Saturn and Jupiter because all the better our telescopes get, the better our instruments get, the more we map these systems, the more stuff we find, and of course the smaller things that we can find as well. So I think honestly, I think it's gonna keep going. I think it's gonna be like, I don't know, 400, 500 for Saturn and
It's so
around the same number
wild.
for Jupiter.
Not like I'm 500 years old.
I know, but wouldn't that be cool? You get to see everything that happens for 500 years.
It would be cool.
That would be very cool. All right, so speaking, I suppose, speaking of cold things, um, you have something cold but very, very different on the list, I see.
Yes. Okay, so we're sticking with March 25th, but like much more recent, 1951, where Harold Ewan and Edward Purcell discovered radiation from cold hydrogen in the galaxy. So the detection was made using a radio telescope with a horn antenna sticking out of the fourth floor window of the Lyman Physics Lab at Harvard University. Ewan was the first to observe and detect natural hydrogen. Purcell was his thesis advisor, and Ewan was pursuing his graduate studies in physics on a GI Bill after the Second World War. Purcell suggested to Ewan to study prior work on the hyperfine line of neutral hydrogen. And they weren't sure if they'd be able to detect the line with their instrument or if the line was detectable at all. There'd been a 1945 paper by Dutch astronomer H.C. van der Hulst, who had expressed pessimism at the possibility of such a detection. And Ewan was worried that he might be walking straight into like a negative thesis. But Purcell encouraged him to try, and they agreed that Ewan's thesis topic should be to construct a microwave spectrometer and find the lower limit on the detectability of the 21 centimeter hydrogen line. So the pair figured the best place to look would be towards the south, just north of Sagittarius, since that's the center of the galaxy, and they expected emissions to be concentrated along the Milky Way. Astronomers had deduced that the gas in the galaxy was mostly hydrogen and that there were very few atoms per cubic centimeter. Their observations, as mentioned, were at 21 centimeter wavelength, which at which only 1 watt lands on the entire Earth. So it was a chance. It was a gamble. It paid off because at the end of their first scan, they had a signal. The results were soon confirmed by both Dutch and Australian astronomers, and Ewan was able to defend his thesis in May of that year. He was awarded his PhD from Harvard. The 21 centimeter line is also known as the H1 line, and it's frequently observed in radio astronomy because those radio waves can penetrate large clouds of interstellar cosmic dust that are opaque to visible light. And observations of the hydrogen line have been used to reveal the spiral shape of the Milky Way, to calculate the mass and dynamics of individual galaxies, and to test for changes in the fine structure constant over time. It is of particular importance in cosmology because it can be used to study the early universe. And due to its fundamental properties, this line is of interest in SETI, the search for extraterrestrial intelligence, and it is also the theoretical basis for the hydrogen maser. So, very important advancement, very important observation for many things to come after it.
Yeah, exactly. Such an amazing setup as well. This experiment, as you say, is a horn out the window. But I definitely, this is another one. Like, I would recommend people to look this up because it's actually a giant sort of like metal cone thing, and it's like sort of going out a window, but it's sticking out of the side of the building, and they had to put up this whole scaffold to hold it. So it's very much, engineering meets maybe not mad scientist, but maybe scientists that didn't have a lot of funding and had to like put up a very haphazard wooden scaffold to hold their amazing horn thing.
Yeah, they had around
Um,
$500.
yeah, and this is the more sort of dodgy or scaffolding looks, that sort of, it always indicates your funding level. Um, I've put up that kind of scaffolding myself, so I know how important it is. But yeah, it really made history in science space exploration, and I mean this paved the way for so many things, including pulsars and quasars and the whole universe that radiates at these radio wave frequencies, and they didn't actually know whether the radio waves would be detectable, from multiple objects. They just sort of said, okay, well, look somewhere along the Milky Way and hope for the best. And now detecting the Milky Way with a radio telescope is one of the sort of first best experiments you can do if you're getting started. So yeah, if we ever get money for a radio, a small radio antenna, I'm looking forward to adopting that one because it's pretty cool. It's really like they didn't just put together this cool new instrument. They borrowed technologies from other areas. They designed equipment as they needed it. They sort of put together engineering with science and this like hardware that had never existed before. Um, so yeah, and they were actually in competition with a couple other groups, as I recall, as well. Um, so they were, I believe, a couple groups in the Netherlands who were also trying to get their detections, and they succeeded, but after Ewan and Purcell. So small science, yay!
Yay. Question for you, Elena. If you get this radio thing going, whose window are you going to stick it out of?
I'm thinking maybe just on the roof.
Okay.
Um, that would be
Might be
probably
easier
the way to
to
go.
convince the lawyers.
Yeah. Well, I'm actually thinking of on the roof in the parking garage because we have a little cage. So,
Oh,
for those of you who don't know, and this is especially relevant this summer, we have a little cage on top of the parking garage roof for the small telescopes of the Allan Carswell Observatory. In the summertime, we take the telescopes out and do observing up on top of the roof. We also do solar observing, which is really fun. Those sunspots right now are putting on a great show.
they are.
Like
Saturday was
really,
awesome.
yeah, really good. But we have this like flat rooftop thing, and I think it would be the perfect location for a radio telescope.
Agreed.
You just need so I don't know, see the website for donations and all that good stuff. But yeah, the sheer impact that this so-called small science had really set up scientific space exploration for all kinds of things. And today, radio astronomy is a huge area, and of course, now we have things like ASCAP in Australia that are and the Square Kilometre Array that are just taking up massive, massive amounts of space doing awesome radio astronomy things. Um, so yeah, great moment in history, actually.
Hmm.
Very fun stuff. Well, since we're about halfway, let me go ahead and just remind everyone. So, probably a good time to remind everybody that you are, in fact, listening to York Universe. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Our website is yorku.ca/science/observatory for all of our previous episodes, chat, questions, or content on, any kind of things you're interested in. We have, of course, our Twitter, Instagram, and Facebook posts running. And tonight, you're listening to Julie Tomei and Elena Hyde, and we're discussing cold things and discoveries, apparently. So right now, I will just sound out that the OPV, the online public viewing, has opened. So the clouds have parted above the Allan Carswell Observatory, which means we have actually opened the telescopes. So if you are thinking of tuning in live to YouTube to join the OPV online public viewing, it looks like they're going to be able to show some live skies tonight. I believe
Huzzah.
they have some wonderful stars lined up. Maybe even that comet if we can get there before it sets. So all of that happening basically right now. um, so highly recommended. All right, so before we go, maybe I'll go ahead and round off our last item, and then we'll do the reminders just to keep it somewhat in order. So I actually have one more cold connection here. I have a discovery that was made on March 31st of 2005. So this is actually a little something different, fairly recent. And this is the dwarf planet Makemake. And I think I'm probably saying it wrong.
I think
Um,
it's Makemake.
Makemake? Okay, we'll go with that. That sounds more correct. I need to check the pronunciation on that. But this minor planet or dwarf planet is the second largest of what's known as Kuiper Belt objects, and that means cold. They are the icy ends of the solar system. They are, extremely low temperature objects, and the things out there get so incredibly cold. It's very hard for us to conceive of. Chemistry becomes different. Liquids become solids. Gases become solids. Gases become liquids. Everything starts to behave differently because, of course, of your pressure and uh, diagrams for your gas distribution. Things get strange. It gets too cold to snow in some cases. So, what about this object? So, this was discovered in 2005 by a team who was actually out there looking, and they give it an initial designation, and minor planet number, and then they renamed it. They gave it an official name, I suppose, after they realized just how awesome it was, which was Make, yeah,
Mhm.
which is a creator god in the Rapa Nui mythology of Easter Island. And this was actually adopted by the International Astronomical Union. So this became its official name. And sort of once it gets on the list of the IAU, that's okay, that's its name now. So it was adopted under the expectation that it would prove to be a dwarf planet, and of course it was. They were discovering this object, and this is actually one of many very interesting discoveries from Palomar Observatory, which is another amazing historical telescope, which I super recommend anybody visiting if you do go down into the US in California. Wonderful place. So they had been tracking other objects in the solar system, and they found this one a bit of serendipity. And they were actually part of the famous Palomar Observatory's digitized sky survey. And the Palomar Sky Survey used photographic plates, and this sky survey is pretty famous for good reason because it has led to so many discoveries. And because it is mostly online now, you can actually find some of these original plates if you feel like having a look. So it is relatively bright, so, compared to other very dim things. So it's about a fifth as bright as Pluto, but it wasn't discovered until many other fainter Kuiper Belt objects. So it actually took kind of a while to find it, probably due to the fact that it has a little bit of an unusual orbit. It's at what's called basically a high orbital inclination, or it's tilted respect to the orbital plane of the solar system. So it's kind of at a strange place in its orbit where it makes it a bit harder for us to find. It's actually the brightest of the trans-Neptunian objects after Pluto. So Pluto and some other very, very cold things around the orbit of Neptune. So if you're counting Jupiter, Saturn, Uranus, Neptune, Pluto. Well, Pluto sometimes dips into Neptune's orbit. And anything that does that can be a trans-Neptunian object. And it turns out there are actually a good number of things that do that. Once you get out to these high distances from the sun, there's lots of small things and a lot of space to cover. So going, basically um, at a greater average distance than Neptune, but its semi-major axis has something like 30 astronomical units, or 30 times the distance from the sun to the Earth. So these are really, really, really far away, which is why they tend to be really, really, really cold. So this is a temperature that you can measure in Kelvin. And Kelvin is the temperature scale that starts at absolute zero, which is the lowest temperature that can exist as far as we know in physics. This is minus 230, sorry, uh, the actual temperature is 40 Kelvin, which is 40 degrees above that absolute zero. And this is about minus 230 Celsius. So very, very cold. Its surface is covered with methane, ethane, and maybe even nitrogen ice. So even nitrogen, which is just air for us, becomes a solid out at this temperature. It actually shows signs of geothermal activity, and there's some evidence that this distant, incredibly cold object might even have some kind of subsurface ocean or something going on, which would be amazing. Because you'd have to think what's going to be the first thing that's possible to make a liquid when you're starting off that cold. This is one of the fun things, of course, out at this very, very large distance from a sun. You do tend to get things that are lower density, icy objects that have strange solids of methane or maybe even ethylene, acetylene. There's basically all kinds of interesting stuff. And there's a lot of similarities as well with Pluto, which of course gained a lot of press not too terribly long ago when it was reclassified into a dwarf planet as well. So this is, and just to be make sure everybody has it, the official definition of dwarf planet, which does include Makemake and now Pluto as well, is basically any small planetary mass-like object that is gravitationally rounded. So it's big enough to be gravitationally rounded, but it doesn't achieve what they call orbital dominance, which is a little bit of a problem because Neptune, of course, has all these trans-Neptunian objects. But the criteria is it clears the orbit around its location such that it becomes gravitationally dominant. So Neptune sort of squiggles off the hook that way, I suppose. Um, but yeah, it's part of a whole interesting class of objects. The largest of these are Ceres and Pluto, and then Makemake is in the same class as things like Eris and Sedna and Haumea and a few other really fun, dwarf planets. And the fact that they might be geologically active is just fascinating to me.
Yeah, that's really interesting.
Crazy stuff. All right, looks like we've got a few more objects coming up live on OPV at the moment. So let's just take a minute and do a couple quick reminders for people. We have mentioned, of course, the comet Pons Brooks was up in the sky tonight, I should say. Now, of course, there are other things happening, but this being related to the upcoming eclipse, we still have some solar viewing events happening. So if you're trying to learn about the sun and sunspots and all that cool sun behavior that's happening, we did
And get
actually just get
yourself,
some aurora.
yeah.
Sorry?
And you can get yourself a pair of solar glasses.
Yes, of course. And this is at all of our solar events. We'll have free solar glasses to give out to the public. And the next one is First Clear Day, April 2nd to the 6th. So that means on one of those days, not all of them, because we would all burn out immediately if we tried to do that. But whichever one is clear, starting on April 2nd. So April 2nd, we check. If it's clear, we do it then. If it's not clear April 2nd, we try again on the 3rd, and then so on for the 4th, the 5th, the 6th. And I'm really hoping we get a clear day on one of those. Whichever one it is, we will be observing at the Allan Carswell Observatory on the Arboretum parking garage roof with lots of glasses to give away, solar telescopes, games, all kinds of things. So feel free to, again, I will just advertise the website, I suppose. So you can always see all that information and more on our same website, yorku.ca/science/observatory. And then you just click on the solar eclipse button, and that will take you to the solar eclipse website with all the events and lots of information and solar safety, which is huge. So the basic reminder for this week is that this week we're having a regular tour on Wednesday, but of course then we're gearing up for the first clear day event, April 2nd through the 6th. And that's going to be really fun to get everybody out there viewing sunspots and learning about, coronal mass ejections and the aurora that can be caused from them. So if you're wondering why we got an aurora watch recently, might have something to do with those big sunspots that we've been seeing on the surface.
Such beautiful groups of sunspots on Saturday.
Yes, and they're actually still up, I believe. The group of sunspots has moved across the surface, but
As they
it's
do.
still, yeah, still visible, but very cool.
Nice.
All right, so I think that's most of the reminders I wanted everybody to have for first clear day, just so everybody knows what that is. And right now you get to watch the new domes moving around in the telescope
Yes, so
at York
exciting.
University. So if you're live, you get to see the bit of the show. Robots are pretty cool, but they're even better when they're telescopes.
If anyone wants to attend an online event to learn about safety for eclipses
Oh,
and hear
yes.
some eclipse stories, Elena and Ian McLennan will be uh, doing a presentation tomorrow evening at 7 p.m. Toronto time through Space Place Canada. So you can head over to spaceplacecanada.ca to sign up, uh, free registration to get the link to join us there, or head over to the Space Place Canada Zoom at the appropriate time, 7 o'clock tomorrow evening.
Yes, absolutely. That should be fun because we will be going over solar safety as well.
Mm-hmm.
Very important. Do not look directly at the sun.
Yeah.
Please, nobody damage your eyeballs.
Yes. You only
But
get one
yes,
pair of those.
yeah, so far, yeah. Um, I mean, I suppose it could be argued that, most of us get two sets of teeth, but eyeballs just the one.
Eyeballs, just the one pair.
Yeah. All right, so I think we should probably go on to some pretty cool news items that we have here. There's again so many things happening, but I love your news article, Julie.
Yes. Well, I'm always a sucker for a news article where students get to be involved in science in a meaningful way. So there is a program called the Galaxy Explore program at the Shabbat Space and Science Center in Oakland, and that is in California. And it is a project aimed at democratizing science and fostering educational enrichment. And through this program, a group of high school students has contributed to exoplanet research. The students work with researchers from the SETI Institute and backpack-sized digital smart telescopes made by Unistellar. And they helped observe and confirm the nature of TIC 139270665b. We are so good at naming things, Elena.
Yeah, so you can call it, is that number long distance, or can I call it from the?
Let's see. Yeah, probably long distance. So that is a warm, dense sub-Saturn planet orbiting a metal-rich G2 star. Dr. Dan Peluso from the SETI, who's a SETI Institute affiliate, said, quote, in such endeavors, participants are learning by doing, and the doing is not some meaningless task. Instead, the doing is the astronomical data collection, which in the past has been mostly left to professional astronomers and their observatories, or with highly skilled citizen astronomers with technical telescope setups, end quote. The students had a challenging but meaningful task to capture the second transit of the planet whose orbital period was poorly understood. The unistellar telescopes are easy to set up and control, and that takes down one of these barriers to participation. The initial clues that TIC 139270665b's existence was initially discovered by a citizen science group inspecting the TESS, or Transit Exoplanet Survey satellite photometric data, and further study by analyzing radial velocity data from the Lick Observatory. Peluso and Dr. Paul Dalba and their team were able to confirm that the planet was there and that it has a sibling planet, or repeat that whole string of numbers, C. The photometric data from the Global Unicellular Citizen Science Network, including the Galaxy Explorers, was not able to definitively confirm the second transit with 100% confidence, But their data was useful for the exoplanet study since it helped rule out times when the transit was not happening, and because it helped the scientists to learn valuable lessons about how to approach citizen scientist campaigns like this one in the future. The students gained real life skills and insights into the scientific process, from planning and conducting observations to analyzing data and contributing to a scientific publication on which they're all co authors. How cool is that?
Awesome. And this is something I so agree with is that when you have any kind of students helping out with a real science project, they 1000% should go on as co-authors.
Yeah.
Um, like it's just so I've seen arguments against it, and I'm like, no, 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 no. It's so important to credit them because their contribution was part of that science. Um,
What's the argument? There'd be too many authors. There are papers from like these big
I
NASA,
know.
uh, you know,
Well, the co-author
whatever.
list is like 3 pages long.
Right.
There's no reason
You
to
do
leave
it for
people
grown-ups,
off.
to do it
Yeah,
for kids.
exactly. And it really lets you be part of something in such a cool way, as you said. And I mean, I remember when citizen science was just, SETI at home,
Yes.
basically.
Put this app on your computer, let it use your extra cycles.
Yeah, and I mean, nothing against SETI. It was cool. It did inspire people. It got pretty famous for a while.
Oh yeah, I did
But
it.
it's so much cooler when you can actually be involved in it. And of course, I will just have to say that like if people listening are interested in citizen science projects. There are so many now.
That's right.
There's my one of my favorite ones, which is Be a Martian, which lets you go to Mars and identify and measure craters and mountains. Really, really fun. But there's just so many out there right now where you can actually be part of the data and part of the measurement. Not all of them will make you co-authors, but there's some really cool ones.
Yeah. And students who participated in this, they like in the press release I read, some of them were like, yeah, and then I got to go work at the summer program at this observatory, and another one's like, I'm totally studying astrophysics when I go to university. Like it can really inspire people to um, choose careers in science.
Oh yeah, and I mean this is how really cool stuff gets invented too, is by people coming into science with cool ideas and new brains and who knows, one of them will build the next, I don't know, giant space detecting something horn.
Yes.
Um, so building things is good. All right, so I have a few more minutes. I think we can probably hit that last news item that we
Let's
had up
do
for
it.
today. So in the spirit of exploration and discovery, I suppose, I'm going to continue this extremely cold theme that we have going and talk about some ways of or signs of detectable life from moons in our solar system. And this is extraterrestrial moons. So I'm not talking about pockets of ice that they found on Earth's moon, which are interesting in and of themselves. But these are some of these ice encrusted oceans out in the icy outer solar system, which, as we have discussed before, just gets colder and colder and colder. So the farther out you go. So the moons of Saturn and Jupiter do have very sort of icy casings. And in particular, there are some moons that have a real ice encrusted sort of appearance. The outer part of the moon appears to be an ice shell of some sort, and then there are serious evidences for oceans or liquid water underneath there somewhere. And some of the moons have really, really strong evidence. Of course, Enceladus, which is the sixth largest moon of Saturn, so smaller, about the tenth of the size of Titan that we were talking about earlier. And this is a smaller moon, but it's really interesting. It's covered by fresh, and fresh means recently put on there, clean ice, which means it is incredibly reflective, which is great. It actually shines out there and makes it somewhat easy to spot. And of course, this one was also discovered by Herschel, um, and it has a very strange behavior, and that it looks like it seems to be venting geysers or jets of icy particles. And it's been sort of spewing out water such that it kind of has a ring. And this is actually within Saturn's E ring. So if you're counting the rings of Saturn. Now, the E ring that it lives in is unstable with a lifespan of 10,000 to a million years. So Enceladus, this icy moon, is actually replenishing the particles of ice and reflective materials in this entire ring of Saturn as it spews things out and goes around Saturn. So it's literally like sitting there like a kind of a jet thing, like if you've seen the trails that jets leave in the sky, it's kind of doing that, but with water around its orbit. So you can just, see it continuously. And this is insane because it means that the actual water that was in the moon is just sitting out there and you can just fly through it. So we had visual confirmation of venting in 2005. And of course, if Enceladus is water rich, we can't say water rich without talking about Europa, which has been known to have a real water ocean underneath its crusty, icy surface for quite some time. And what about this water? How are we going to detect life in this water? So this article is from University of Washington, and it's called "Signs of Life Detectable in Single Ice Grain Emitted from Extraterrestrial Moons." So the cool thing about this is that even a very, very small amount of material could do life detections from these kind of icy moons if life exists there. So you could have a mass spectrometer, for example, and send it out to Saturn or to Jupiter, and actually be able to look for life, and in particular, tiny life. So tiny life from tiny bits of material. That's what they want to look for. So this is a bacterium, which has a really, really hard name to pronounce. It's something like Sphingopyxis alaskensis, which is the last part is it's a bacteria, which is found in the waters off of Alaska, very, very cold waters. So lots of studies use bacteria as to see, can it survive in various environments? Can it survive with very few nutrients? Can it survive in extremely cold environments? And the ones in particular that they're talking about are so small, the bacteria can fit inside ice grains. And those ice grains are what are emitted from an ocean world like Enceladus, and maybe, in a lesser extent, Europa. So if we don't have to land there, we don't have to build a submarine. I mean, it would be cool if we built a submarine. That would be amazing, but you don't have to be able to detect this kind of life, this kind of bacterium that can grow in or on a single ice grain. And you could end up with different molecules and different ice grains. And obviously, the more you get, the better your results will be. And you have to analyze, and this is kind of a cool part, you have to analyze each ice grain individually. So whatever sample you take, you're going to be counting the grains one by one to look for life. Um, the same researchers recently did a study showing that phosphates on Enceladus were present. And this, so Enceladus of the two now appears to contain energy, i.e., gravitational heating. It has water, not just ice, it's active. It has phosphates and other salts. So, carbon based organic material, maybe not unlike what Earth has. Um, so maybe it can make bacteria. And of course, life on Earth is thought to have been, pretty much founded in the oceans. So, if true, this would be a really cool way to detect life. And of course, if the Europa Clipper happens, which is an upcoming mission that is has a launch window opening later this year, October 10th, 2024. Fingers and toes crossed, it gets to Jupiter and goes to Europa. Might help us do some of this.
That is so cool.
Literally. There's
That pun was
literally and
not
figuratively.
intended, but I will take it.
Yes. And of course, with all of this great excitement and discovery in icy cold things, I hope it gives our listeners a chance to set their icy outer solar system imaginations going. All right. So that's probably all we have time for today. So thank you everyone for joining us tonight. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Julie Tomei and myself, Dr. Elena Hyde. You can always connect with us on any of the socials, and of course, you can always check our website for show notes, content, updates, and contact info at yorku.ca/science/observatory. Thanks for tuning into York Universe. Clear skies, and have a good night.
Good night.